Part of this is what's the definition of a parallel line, Yusuf? Two lines that lie in the same plane. Same plane, but never intersect. Okay, next one up was skew. Does somebody want to volunteer for skew? Okay, Yusuf? Two lines that do not lie on the same plane. Two lines that do not. Thank you, sir. On the same plane and do not intersect. Okay, next one up. Natalie, hon? Yep, two lines that intersect to form a right angle. Thank you. Okay, last one here. We have transversal. Jasmine? Thank you for giving me a second. A line that intersects two or more coplanar lines? Yeah. Okay, and what's the rest of it? At different points. Thank you. Tag teaming it over there. Okay, so that's our vocab part for this page. Our next one up says we want to describe the relationship between JL and MN. Can somebody tell me the relationship between those two lines? JL, Delaney? They're parallel. Okay, and then we have, I'm going to do it in a different color so you can see it. We have NO and we have KL. E? They're skew. Can you see it if I wrote skew on that box? Probably not. I'll go here. Skew. Okay, on this side we have DH and GH. DH and GH. What relationship do we have there? E? Perpendicular. I wrote the symbol since I didn't want to spend the time to write out the huge word in that little small space, but you can write out perp. Okay, we now have BF. BF and CG. Natalie? Parallel. Okay. Okay, so on this one, it doesn't really give you any information here. It just wants you to identify a pair of these. So I'll go through it quickly, and I'll just identify one example of all of these. So the first one is corresponding angles, and corresponding angles are in the same position in reference to their line and the transversal. So 1 and 2 are an example of corresponding. Consecutive is the same thing as same side interior. An example of that would be 3 and 4. They're on the same side of the transversal inside our lines. Back here we have alternate interior. An example of that would be 5 and 6. They're on opposite sides of the transversal inside the two lines. Alternate exterior, an example of that would be 7 and 8. They're outside the lines, opposite sides of the transversal. And then we have vertical angles, and option for that would be 9 and 10. They lie directly across from each other. That's that kissy fish when they intersect. They don't share a common side. And then you have linear pairs, which would be 11 and 12. And then that's where the non-shared side forms a straight line. So those are going to be supplementary. So we want to classify these angles. What is the relationship between 1 and 2? Natalie? Alternate exterior. Thank you, ma'am. Alt X. Okay, 3 and 4. Same side. And then just make sure you put that int. Same side interior. Ooh. And then over here we have 5 and 6. Corresponding. And then we have 7 and 8. Alternate interior. Okay, so moving on to number 5, we want to tell the relationship between the two angles named. I'm pretty sure this is what your test looks like tomorrow. I'll give you guys examples, and you tell me what the name of them are. So the relationship between 1 and 7. Alternate exterior. Okay, 4 and 6.
Alternate interior.
Alternate interior. So now we're on 8 and 7. What's the relationship between 8 and 7, Sierra? Linear pairs. Thank you, ma'am. Okay, after that we have 3 and 8. What'd you say, hon? None is the correct answer. There is none. Okay, we're at 5 and 3. Yep, Natalie? Alternate interior. And last but not least, 2 and 4. Vertical. Okay, so the next part is naming all of them. So, I feel like everybody's done a really good job volunteering. Do we want to start over here? So, Kevin, can you tell me a corresponding angle? You can. Same side of the line, above or below the transversal, right or left?
2 and 8.
So we have, those were vertical, but 2 and, so that's above the transversal to the 2 and 4. Yep. 2 and 4. Dante, you want to tell me another one?
2 and 3.
So 2 and 3 are same side interior. So it would be something like 3 is above the transversal to the right. So the other one that's above the transversal to the right would be 3 and, you're close, above the transversal. 3 and 1. Yep, DeMarcus? 7 and 5. Okay, Chris?
8 and 6.
8 and 6. Okay, so after that we have alternate interior angles. Who would like to volunteer for alternate interior? Natalie? 3 and 7. E, do you want me to do the other one?
2 and 6.
2 and 6. Okay, when it says consecutive, it means same side. Same side interior. Who would like to volunteer for same side interior? Natalie? 6 and 7. Okay, and we have another Natalie? 2 and 3. Okay, alternate exterior angles. We have 1 and 5. And Kevin, you want to do the other one? 8 and 4. Okay, vertical angles. E?
4 and 6.
4 and 6. Now give me the rest of them.
3 and 5.
3 and 5.
1 and 7.
1 and 7.
8 and 2.
8 and 2. Does anybody want to give me all of the linear pairs? Okay, Taylor?
1 and 8.
1 and 8.
1 and 2.
1 and 2.
2 and 7.
2 and 7.
7 and 8.
7 and 8.
3 and 4.
3 and 4.
3 and 6.
3 and 6.
4 and 5.
4 and 5.
5
And 5 and 6. Nice job. Now hit resume. Okay, so if 2 parallel lines are cut by a transversal, then the corresponding angles are what? 2 lines cut by a transversal, then the corresponding angles are congruent. I'm going to use my congruent symbol. Okay, so over here it says line A and B are parallel. How did we know that they were parallel? Because they're like that. It's given in our picture. We see it. Okay, so then we know that angles 1 and angle 2 have to be congruent. And how did we know that? Yep, by that corresponding angle postulate. Postulate. Our next one up, we have alternate interior angles theorem. If 2 parallel lines are cut by a transversal, then pairs of alternate interior angles are... So we know alternate interior angles and parallel lines are congruent. And so once again, we see that it is given that the lines are parallel. And if we're looking at 3 and 4, we know they're congruent by that theorem. Alternate interior angles theorem. THM. Okay, after that we have alternate exterior angles theorem. If 2 parallel lines are cut by a transversal, then the pair of alternate exterior angles are congruent. Okay, and that means again we know that A and B are parallel because it's given. We know that angles 5 and 6 are congruent by the alternate exterior angles theorem. Okay, and then this one's just one that's slightly different. This is the same side interior angle theorem, If two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Yep, so we know that supplementary means they add up to 180. So again, we know it's parallel because it's given. And we know 7 and 8 are supplementary by this theorem. Same side, int angles theorem. Okay, and number 3, I'm not going to make you do that step. We're just going to cross it out. So we are looking at angle 2 and angle 6. What's the relationship between angle 2 and angle 6? They're corresponding, and we know corresponding angles are congruent. So that means the measure of angle 6 has to be 113. Over here, we're looking at 4 and 6. What's the relationship between 4 and 6? Yep, alternate interior. And we know alternate interior angles are congruent. So the measure of angle 1 has to also be 75. Oh, I did it in the wrong spot. I apologize. 4 and 6. So that goes here, alt interior. And we know that the measure of angle 6 has to be 100. Okay, 1 and 3. What's the relationship between 1 and 3? They're vertical. We know vertical angles are congruent. So that means the measure of angle 3 has to also be 84. We have 7 and 1. What's the relationship between 7 and 1? Alternate exterior, alt x. And we know that the measure of angle 1 has to be what? 75, because alternate exterior angles are congruent. And then we have the measure of angle 3 and the measure of angle 4. 3 and 4, what's the relationship there? Linear. And we know linear pairs are what? They're 180. So we have 180 minus 81, which gives me 99, right? 99 degrees. Over here we have linear pair. Let me finish that up. Okay. So over here we have 6 and 3. 6 and 3 are what? Same side. Let's do this. Same side interior. And we know that same side interior angles are supplementary. So we have 180 minus 111. That gives me 69 degrees. Yep. Okay, on the next one, example 4. We know that the measure of angle 1 is 75 degrees. This is like the one you guys had in the review yesterday. So if we know that the measure of angle 1 is 75 degrees, how do I find the measure of angle 8? What's the relationship between 1 and 8? They're supplementary because they are linear pairs. So 180 minus 75. The measure of angle 8 is what? 105. So I'm going to put in 105 here. We know here that this one's going to be 75. So we have angle 7. What's the relationship between angle 7 and angle 1? It's going to be 75 because they're vertical. Okay, over here we have the measure of angle 2. What's the relationship between 2 and 8? Vertical, so we know that also has to be 105. Moving on to angle 3. What's the relationship between angle 1 and angle 3? Not vertical. They're corresponding, and we know corresponding angles are congruent, so this one's going to be 75. Angle 6 and angle 8 are also corresponding, so you know that angle 6 has to be 105. And then angle 5 and angle 1 are what? Alternate exterior, yep. And we know that that means that this is 75 degrees. And then angle 4 and angle 8 are also alternate exterior, which makes this one 105 degrees. Do you have any questions so far? So when it talks about the pattern, I won't make you answer that yet. We'll talk about it right here on this part. I'm going to scroll up so you can see it a little bit better. So the part where this person who created this related it back to Harry Potter, she says, or he says, mark an angle with a dot. It doesn't matter which one you mark. I'm going to mark this one right here. And then it says, find a vertical angle and mark that with a dot. So the angle that's vertical from it would be this one right here. And then it says, copy the same pattern on the other parallel line. So I'm going to come down here. I'm going to put a dot here and a dot here. Connect the dots with the line. And you see that you ended up with a scar that looks like Harry Potter's scar. And we see that all the angles we just connected with those dots are congruent. So if they have a dot or are blank, they are the same measure. If one has a dot and the other's blank, it's different. It's going to be supplementary. Okay, on to our next one. If these are parallel, angle D or line DC, segments DC and AB, are the angles congruent or supplementary? So our first one is DHG. I'm going to draw these on here and then I'll erase them. So DHG. And the next one is HGA. Are these angles congruent or not congruent? Congruent or supplementary? They're congruent, and we know because it is alternate interior. Okay, we also have, I'm going to erase those two. I'm going to look over here. We have FHC, and we have DHG. What do we know about those two angles? They're vertical, and vertical angles are? Yep, so we know they're congruent, vertical angles. Okay, our next one, we have, let me erase that. We have BGE, and we have FHC. What do we know about those two angles? Alternate exterior, and what do we know about alternate exterior? Yep, they're congruent. Alternate exterior. Next one up. We have angles EGA, EGA. We have GC. Hold on, let's try again. GHC, GHC. What do we know about those two angles? And we know corresponding angles are congruent. And then we have two more on this page. We have angle AGH, AGH, and we have angle EGA, EGA. We know they're going to be linear, so that means they are supplementary. Nice job. Linear, sup. Okay, over here, last one. I'm going to go here. We have DHG, DHG, and we have BGH. What do we know about those two? Same side. And that means they're sup. We want to talk about the relationship between these two angles. What's the relationship here? They're going to be parallel lines, but the one that we have this measure for and this one? Corresponding. And we know corresponding angles are? So we have corresponding. We know the angles are congruent. So I'm going to do 17x minus 4 equals 12 plus 15x. We got to combine those like terms. Like terms are the things that have the x's and things that don't have the x's. So what am I going to do first? So we're going to subtract 15x from both sides. Okay, so we end up with 2x minus 4 equals 12. We got to get the things without x's together. How do I do that? We're going to add 4. If we add 4 to both sides, we end up with 2x equals 16. What do we do for our last step here? Divide both sides by 2, and then x equals 8. Okay, our next one up, we have those two angles. What's the relationship of those two angles? Same side interior. We know same side interior are? Yep, there we know that they're sup. So what we're going to do here is we have x plus 67 plus x plus 127 equals 180. Okay, we got to combine like terms that are on the same side of the equal sign. So x plus x gives me 2x. Can anybody tell me what 67 plus 127 is? 194 equals 180. We got to get those like terms together over the equal sign. So I'm going to subtract 194. Okay, so that gives me 2x equals negative 14. Divide by 2. X equals -7. Nice job. Okay.